Welcome back. We are going to talk about square roots in this lesson. And in order to understand what a square root is, you need to understand what a perfect square is. It turns out that perfect squares and square roots are inverse operations. So for example, if you have numbers like 1, 4, 9, 16, 25, those are all perfect squares. And a perfect square is a number that you end up with when you square an integer. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. So those are called perfect squares because it's a number times itself. A square root is the result of taking the radical, okay, and finding what that number was before you squared it. Okay, so it's two equal factors. So like when we have 5 squared giving us 25, the square root of 25 gives us 5. So 5 is the square root of 25. This symbol that you've seen right here is called a radical sign. We often call it a square root sign, but technically it's called the radical sign. Okay, and it gives us both a positive and a negative square root. So every square root gives us two answers. Okay, it gives us both a positive and the negative. But generally, when we're finding, if we just have the radical sign by itself, that means the answer that we want is just the positive value. So we'll talk a little bit more about that right here. To find the square roots, this one says find the square root of 64, and since there's no sign with that, it's indicating that we just want the positive one. Okay, so the square root of 64, you can punch these in on your calculator if you don't know them. The square root of 64 is 8, and we're only going to list the positive value. Even though negative 8 squared would still give us 64, this just indicates the positive value. Now this one over here, the square root of 25 over 36, see how it has a negative in front of it? That means we want just the negative value. So we're going to go ahead and take the square root of both the top number and the bottom number. We're going to separate those out. And I think we've talked about this before. We can write this as the square root of 25 over the square root of 36, and then evaluate each one of those independently. So the square root of 25 will give us 5, and the square root of 36 will give us 6, and then we just put a negative out front. So negative 5 6 is our answer. And if we were to go backwards and square this, 5 6 and square that, negative 5 6 squared gives us 25 36, but we're looking for the negative value. Now this one you're not going to probably recognize, plus or minus the square root of 1.21. So I definitely want you to learn how to find these on your calculator. I'll work with you in class if you have questions on that. Please ask me how to do that on your calculator or on your laptop, and I can help you out with that. So the positive and negative value are what we want on this one. Okay, so we want both values. That means plus or minus. And so if you punch that in on your calculator, you will get 1.1. And so our answer will be plus or minus 1.1. You can write it this way. Let me go ahead and underline that so you can see that. This is the common way to write that, where you have two answers. And what it means is you have both positive 1.1 and negative 1.1. There are two answers in there. Okay, so I want you to be able to recognize that notation. So as a definition, if n squared, if we have a number and we square it and it gives us a, for example, 5 squared would give us 25, then plus and minus the square root of a is equal to n. So that's just the algebraic way of writing what we just talked about. So let's go ahead and look at how we would practically use that. For example, if we have t squared equals 169, how would we solve that for t? Well, what we would do is we would take the square root of both sides. So first we write our equation, and then we're going to take the square root of both sides. So let me go ahead and write that in here as well. So if we take the square root of the left side and the square root of the right side, okay, the square root of t squared, the square root and squaring are inverse operations and they cancel out, and that's how we get just t. And when we take a square root, we always get two values. So we get plus or minus the square root of 169. And then if you punch that in on your calculator, that gives you plus and minus 13. So our two answers are positive 13 and negative 13. Here's a slide where you can go ahead and try a couple of these on your own. I'll give you the answers when you get back. Go ahead and pause the video and see if you can solve these on your own, and we will go through these together. All right, I hope you had a chance to try those. Let's take a look at letter D. Letter D says 289 is equal to a squared. So first of all, let's just rewrite 289 is equal to a squared. So what we want to do on both sides to get rid of the squared, remember we're trying to get a by itself when we solve an equation, we need to take the square root of both sides. Okay? Then I'd like to see you cross these out, that the square root or the radical sign and the squared sign cancel each other out, and you end up with a is equal to, now whenever we take the square root we do end up with two answers, so you show that by putting a plus and a minus sign. And I believe that one is 17, if my memory serves me correctly. Let's just double check that. Yes, plus and minus 17. All right, how about letter E? Same process on this one, okay? So first thing we want to do is to go ahead and rewrite the equation. I'm going to do this one in a different color. Let's try blue. So we're going to have m squared is equal to 0.09. So we want to take the square root to get rid of the squared, but whatever we do to one side of an equation, we must do to the other. Show me that these inverse operations cancel out, and we get m is equal to, and then write your plus or minus. Now what is the square root of 0.09? And that should give us 0.3. Okay, plus and minus 0.3. So let's take a look if we got that one correct. So 0.3 and negative 0.3. And the last problem, letter F. Let's do that one in green. All right, so we have y squared is equal to 4 over 25. So remember, we're going to take the square root of both sides to get rid of the squared. And when we have a fraction, we're just going to divide that up. So first of all, we're going to cancel out the inverse operations, and we're going to get y is equal to plus and minus. Now I'm going to divide these up. Square root of 4, and in the denominator I have the square root of 25. So we get y is equal to plus and minus 2 over 5. And let's go ahead and take a look at our answer. And there we have it, 2/5 and negative 2/5. So we did okay on those. So sometimes it doesn't make sense to have a negative answer, okay, when you're talking about distance or time, things like that, where negative answers don't make any sense. We will only use the positive or principal square root. Okay, you'll see the word principal square root. That's what that means, is just the positive value. So here's an example from history. It says the base of the Great Pyramid covers an area of about 562,500 square feet. Determine the length of each side of the base. So we have a square base for a pyramid. So I don't know if you can visualize that. Not sure if I can do a decent job of drawing this. We'll see. So if I have a square base, not real square there, but use your imagination, and then each of these connects up to the top, and I'm not doing a very good job of that. That doesn't help. Okay, I'm going to erase that. Never mind. Too tough to draw with the slate here, so I'm going to just stick to what I have on my slide. The area is equal to the square of the length of a side. So if we have a square base, then its area is the side squared. So here's our equation. S squared equals the area that was given to us. So how do we solve this? Okay, well that's exactly what we've been doing, is we want to go ahead and take the square root of each side. So I'm going to take the square root of this side and the square root of this side of the equation. And when I do that, the square root and the square cancel, right? Those are inverse operations. That's how I end up with S. And when I take a square root, I get two answers. But in this case, remember we talked about sometimes that negative answer doesn't make sense. So it wouldn't make any sense to have a length that was negative. So we're going to throw away the negative answer, and we're only going to use the positive or principal square root. So again, this is something you're going to punch in on your calculator, and you end up with 750. So the distance will be 750 feet on each side. Here's another word problem. Let's see if we can reason through this one. It says a concert crew needs to set up 900 chairs on the floor level. If the chairs are placed in a square arrangement, how many should be in each row? Okay, so we basically have a square, and they want to know what the length of each side is. So again, this is just going to be a simple equation like what we had in the last example. Okay, so we've got a row of chairs on one side, a row of chairs on the other side, and the configuration is a square. And we have a total of 900 chairs in this configuration. Okay, so we want to know each side has some number of chairs. I'll just call it C. And it's the same on each side. So our equation is C squared is equal to 900. So to find how many chairs are on each side, how would we do that? Well, we would take the square root of each side to solve for C. So then we get these canceling out, and we get C is equal to plus and minus the square root of 900. Does it make any sense then to you have a negative answer, a negative number of chairs? And no, it does not. So we're not going to use the negative answer. So C will only be the principal square root. And that turns out to be, let me punch that in, looks like that's 30 chairs on a side. And so 30 times 30, if we worked backwards, if we square 30, you could always check your answer. If we take 30 squared, does that equal what we started out with, 900? And when you square 30, yes, you get 900 equals 900, so it checks out. Here's a chance for you to try some problems. Go ahead and work on these 10 problems and bring these to class with you tomorrow, and we can talk about those. See you next time.